5G Real-Time Analytics, the Last Mile of Automation, sponsored by Ribbon. Before we begin, I would like to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Near the end of today's presentation, please take 1 minute to help complete the survey that's on your screen. Your feedback is extremely helpful. An on-demand version of the webcast will be available 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Principal Analyst, Jennifer Clark.
Thank you very much, James, and welcome everyone to today's webinar, 5G Real-Time Analytics, the Last Mile of Automation. I am here with Chip Boyle, who is VP Systems Engineering for Ribbon, to discuss today's topic with you. Good morning, Chip.
Good morning.
And just by way of introduction, I am a principal analyst for Heavy Reading, looking at cloud infrastructure, edge computing, etc. So let's get started. Most mobile network operators that have deployed 5G have done so in a non-standalone architecture where the 5G radio access network, or RAN, connects to the 4G evolved packet core. As of October this month, 2022, our research out of Omdia says that 27 MNOs have deployed a 5G core and launched 5G standalone commercial services, and many others are in the trial phase with their vendor partners. The 5G core utilizes 5G design, utilizes cloud native design principles, which are going to deliver improved agility, efficiency, scalability in comparison with using the virtualized infrastructure. New requirements, such as the demand for low latency applications, are going to be facilitated by the 5G core. However, the journey to cloud native is a challenging one. The MNOs are faced with a number of design and deployment trade-offs, which they have to understand in order to plan the best deployment strategies. One of the most fundamental changes that we see is the role of AI, analytics, automation, the AAAs of the evolving 5G network, and that's what we're going to be talking about today. When we asked our service providers what their top digital transformation initiatives were, the top two are using cloud-based models to improve agility, scale, and efficiency, and as you see, the second one, improving network IT alignment. And these are 1 and 2 by a fairly healthy margin. So what our carriers are saying is that cloud is their most important initiative, and the linkages that have not always been that strong between the network operations side of the house and the IT side of the house need to be improved. And this all paves the way for improved management, automation, analytics. And then we asked them, what are you going to use in order to make this transition? How are you going to become a more cloud-oriented organization using cloud-native platforms? And they came back to us with, well, cloud computing. So cloud computing is not only a goal, but it's an initiative. So we're using it to not only as not only a goal, but we're also going to achieve that goal through the adoption of cloud principles. Second, we have edge computing, we have 5G, we have AI technologies, etc. So we are definitely seeing from the service providers that the move to their digital transformation goals will be enabled by cloud. There is an increasing sense of urgency among the service providers as well in terms of moving forward with their digital transformation and moving forward with their cloud initiatives. And all of this revolves around also moving forward with the 5G core, the 5G standalone architecture that leverages a lot of the cloud initiatives. They are looking to be a little bit more aggressive in the move to 5G and in the move to cloud, but they are hampered by some significant challenges. Their staff is actually a significant challenge. As anybody who's from the CSP environment knows, we have great technicians out there. They are not always the ones that are deploying cloud initiatives, nor are they, we're looking to build up our CI/CD capabilities in general for a move to cloud. If we look at some of the use cases that 5G core will enable outside of what we have already seen with the non-standalone or the EPC, lot of MNOs have deployed 5G RAN in the non-standalone architecture. However, the use cases that those networks can provide, such as more bandwidth for enhanced mobile broadband, they're going to deliver limited benefits. The MNOs that want to deliver genuinely improved network agility and scalability by using cloud-native technologies and address advanced use cases such as the ones that you see there in blue below the dotted line, are going to need to deploy 5G cloud-native core. That will enable things such as you see here, ultra-reliable, low-latency communications. It'll enable the smart factory, autonomous driving, or at least autonomous assisted driving, mobile gaming, AR and VR. Some of these are consumer-oriented. Some of those are, of course, more targeted towards the enterprise. The telcos, we're talking about this union between the move to the cloud and to more tightly link operations and IT. One of the initiatives that the CSPs are moving on is moving some of their IT workloads to the cloud. A lot of this actually pulls in AI, analytics, et cetera. So there's an increasing complexity of where the service providers are gathering their data, how they are massaging and consuming that data, and then how they are improving the operations of their networks through the utilization of that network. But in general, we're seeing the service providers very much interested in moving workloads to the cloud. If we look at how all of this is impacting AI and analytics, or how AI and analytics are impacting it, right now we see an increased focus on AI and analytics. Some of it is due to COVID, where pretty much overnight the service providers found themselves running lights out, zero-touch data centers. They found themselves with a widely dispersed network, as the lines between what is the cloud, what is the consumer network, what is the enterprise network completely blurred. So the ability to manage that environment in a secure, safe, proactive, scalable, agile manner is an increasing source of challenge for the service providers. And with that, I'm going to turn it over to Chip, who will walk us through a little bit of what he is seeing in this market and some examples of how Ribbon is dealing with some of these challenges with their customers. So, Chip.
All right. Thanks a lot, Jennifer. Really good setup in terms of the state of the 5G industry right now. Before I dig into my side of the discussion, I did want to at least put to the forefront, who is Ribbon? You probably know us more as Sonos, Genvan, Nortel from our voice telecommunications lineage. But over the years, we've been transforming to even a wider portfolio that includes data capabilities with the likes of ECI, which is an IP optical set of products, as well as pushing it down to the edges and even into analytics. And I come to Ribbon via the Innova Data acquisition probably back in 2019. Today, I run Ribbon Research Labs, where we look to incubate and innovate ideas and bring them to productization by working with our customers on a regular basis, and primarily in the space of mobile service providers, wired service providers as well, and that crossover with analytics, AI, and in networking in general. So on to what's going to be discussed. As Jennifer was saying, I'll cover briefly, what's going on right now in terms of 5G analytics standardization. This is primarily driven by 3GPP. Then we'll cover a bit of detail in terms of maybe other recommendations when we start to dig a layer or two deeper there, and then some of the technologies and apps that might actually facilitate that. So maybe a bit of a primer first. 5G, you can see it from what Jennifer was showing in terms of it's complicated. They've brought in a number of enterprise technologies in order to solve the problems, cloud compute being in the forefront, but also big data and analytics and AI, machine learning, moving on towards AI. So the standards have taken that up as well, and primarily through a function as part of the 5G core called Network Data Analytics Function, NWDAF. They brought this in place and combined it by looking at all the other network functions that exist in the 5G core. Those are things like AMF and SMF and UPF and so forth, as well as even some of the functions that may be tangential to the 5G technologies. They call those application functions, and that's just a way to bring in auxiliary functions, maybe from the IMS core, for voice services. How do they actually achieve that? They're basically building out RESTful APIs. So one great thing about 3GPP is it does a really great job at defining protocols and defining architectures. So we know how things integrate. And they've done this not just with protocols, but now taking on RESTful APIs and being able to define a full service-based architecture, or SBA, and to allow for the network functions and AFs to integrate with the analytics function, and then allow those same network functions to even subscribe to analytics from the NWDAF as well. So you can see that there can be event exposure functions that are pushing data out from the various 5G core functions. Analytics will actually perform insights and analysis on this, and then that can be pushed out in terms of analytics data. But what's missing? Basically, there's a major focus, rightly so, on the 5G core and how it's running in terms of a control plane and managing the setting up of services, slices, and so forth, but less so on the user plane. Moreover, when we look at this diagram here, we're really not seeing a really tight integration with legacy networks, but we realize that when 5G rolls out, there's going to still be a healthy portion of LTE running in the network, or 4G, that needs to be managed. Voice services will also be working over 4G and then slowly transitioning through VoLTE and VoWi-Fi and so forth. And then there are other domains that also need to be managed and integrated. When we look a little further in terms of the work that the standards have been doing, they've, in subsequent releases, release 17 and so forth, they've actually added more advanced cases. And this is really breaking open the NWDAF function and saying, how can we actually make subfunctions in here and components so we can get best of breed capabilities? How can I actually store the data in the most optimal way and define that as a function? How do I collect and distribute the data? And the ones that are really being pushed is along the lines of machine learning and AI is, how do I do model training and be able to serve out those models to other applications that are running in the network? So it's great. They're really kind of exposing these capabilities and defining, a handful of effectively models that can be subscribed as analytics data. So this ends up being a little bit more complicated model. If I look at it from these sub-functions, then the data that's being exposed from the network functions is pushed through a series of components there. And that'll work through, and there'll be subscribers on the northbound side, and then there'll be the analytics functions will be consuming in the southbound side and so forth. And then as we look even further, now we start creating building blocks. We may want to have regional NWDAFs, even with these advanced components that are either servicing locations. Maybe we have niche-based versions that are tied to voice or edge analysis and so forth. So we can actually start breaking up the NWDAF into a hierarchy and allowing the distributed data to come in, aggregated and analyzed, and then pushed out towards subscribers. So really the architecture is really taking shape, which is great. But as Jennifer was saying earlier, when we look at analytics, AI, and automation, there's a number of complexities there. Everyone's not declaring victory with AI right now. I mean, it's just, it is a complex beast. So within that, we want to kind of take a deeper look in the data models and actions that actually drive this.
Right.
So maybe Jennifer, I'll hand it off to you.
So Chip, let's get started with our first poll question for the audience. Take a look at this. Where are you on your 5G network analytics journey? No analytics, analytics for 5G non-standalone, 5G standalone with standard NWDAF, with advanced NWDAF, or with distributed NWDAF. So take a minute to tell us where you are in your journey, and I don't know, Chip, where do you think the responses are gonna land?
I mean, I would say probably straddling between analytics for 5G NSA and standard NWDAF. I mean, just given where the releases are today and where the evolution of 5G networks are today in terms of the adoption and rollout.
I got to agree with you there. I need a few more people to respond. We already have a bunch. Yeah, there we go. That's pretty good. Let me take a look and see how we're doing. All right, I think we're ready to push this out to the audience. Here you go. So, between not so much between analytics for 5G and standard NWDAF, but even no 5G analytics yet. So that's there's a big opportunity there just in general for the service providers to step up a little bit more to the analytics side of the house, right?
Mm-hmm. Yeah. It probably makes sense. And I mean, I think if they have LTE analytics, the way 5G NSA works, maybe a lot of that data comes for the ride, but there are different networking architectures that may make that a little bit more of a challenge there. So
right.
Very interesting.
Yep, indeed.
All right, let's carry on here. So here I'm talking about what is missing in the 3GPP analytics standards. I want to go a little deeper and to these areas to kind of really make the case here. So we can see here's an existing architecture of what would be a 5G standalone deployment. We have a 5G core, and that's where the bulk of the functions are being performed. As Jennifer was saying, some of them are moving to public cloud, and some of them may stay on-prem. They've split control plane and user plane to allow for each of the functions to run independently and scale on their own levels. And you see onto the left-hand side that will have a number of radio resource capabilities. That this is new radio here under the G-Node Bs. So fairly standard there, and you would access the internet. If we look at the reality is that we have legacy networks as well. So we may have started off with 5G NSA as we were just discussing. And in this scenario, we're just taking those new radios and bolting them onto the LTE networks and allowing for at least enhanced mobile broadband capabilities there. But what we really want to get to is those applications that Jennifer was talking about. And those applications mean that we need to start realizing and understanding the data sets and the data that's actually going on in terms of the traffic patterns and so forth of those applications, for autonomous vehicles, VR, AR, and so forth. These ones that are actually requiring ultra-reliable, low-latency communication and so forth. So it's interesting here because I think there's, we built these out, and in the past, if for those that have been working in mobile in a while, we would run drive tests and even push, FTP downloads and web transfers and video as drive testing. So I'm just, imagining, how we actually have to solve these things when we get to all these other new services that are actually being lit up, because it really is a lot more complex than just 3 different apps, as I was describing. And then we can look at the domains also that sit around the 5G core, as well as even in the legacy networks. We have IMS, which IMS will stick around even as we move into a full voice over new radio. So you'll use it in the early days as probably a hand down to LTE as a fallback. And then in the later days, you can actually use voice over new radio and support it that way. And then if we look towards the edge, we know that there are technologies for edge compute, such as multi-access edge compute and ORAN and so forth, that are really pulling apart and actually giving discrete and disaggregated componentry towards the RAN. And this is actually allowing for the better services, the ability to do the low latency type capabilities and so forth. And then finally, I talked about it before in terms of the RESTful APIs driving a good portion of the 5G core, the 5GC, but there are still 5G protocols going on, and we need to be able to analyze those and understand those as we do rollouts, troubleshooting, and so forth. So this is the parts that I believe are missing, in exposure for from a network domain perspective. When I look at it from a AAA perspective, obviously I was talking about data and models and actions. And when I talk about data, I'm not really talking about data in the sense that we're not collecting data to understand the various functions that are running in the core or so forth. What I'm talking about is how we actually bringing in supporting data in order to generate models, meaning we need to actually have ground truths that are tied to the model so that we may bring in features to train a model. But what are they training against? So one way we can do that is by bringing extra data items from either performance management, from maybe the edge or ORAN, the core, and so forth. Maybe we're actually doing log analysis and pulling in insights from the logs themselves in order to realize and troubleshoot what's going on. So really, there's a lot of opportunity there. And then we can therefore process these models and then push out actions that we all kind of understand today. We've all been in telecom. So whatever we've been doing over 30 years for running networks, large networks like this, when we go to AI and ML, we're actually looking to automate a lot of these. But under the covers, the pieces that we see that we could add include the ability to intelligently capture. If we're going to do models and model training, then we don't really need to actually collect this data all the time. Why do we want to stockpile a bunch of data? There's a whole data glut, or the data race, if you will, where we don't want to lose any of the data we have, but we really don't actually create insights on that. So that could be at a packet level. It could be just fusing different data sets together. And the whole idea of using this data is really to have a continuous training model that has been productized and deployed. We need the ability to manage those models and ensure we have proper governance over those. And then in order to actually have interesting actions or end results, we'll want to actually leverage the cloud and the various orchestration functions that have been deployed in the network and not actually implement things in a silo. So what's our target architecture? This is probably fairly obvious. We'll probably want to start with a cloud native network analytics function itself, where things are broken down and exposed as RESTful APIs. But the basic building blocks have been around for analytics, right? We'll want to be able to pull in data, perform data management. We'll build a number of applications. Some of those applications will have embedded models and so forth. We'll expose frameworks and tools to create models and dashboards and everything else along those lines so that we can build customized solutions. And then we'll want to actually push out those results in terms of actionable closed loop functions. And that means that we're integrating with northbound systems or other systems, right? So this is the basic capabilities there. As we add NWDAF will utilize these base capabilities. Maybe we'll have to add some other items for purpose-built NWDAF solutions for subscription and so forth that are maybe tied to that. But in general, they're aligned along the same building blocks. But what is missing from the perspective of addressing those functions that I was describing before, the missing pieces, we need a programmatic layer. And that programmatic layer really needs to be more intelligent about observability. We need to actually handle model lifecycle management. And then how do we integrate tighter on the orchestration side of the house? All of these are actually tied together, much like they are when we're bringing our data flows in the basic building blocks. These all have a relationship between each other. So digging a little deeper into these programmatic building blocks that I'm talking about here. If we look at intelligent observability, what are we talking about here? We're really talking about data in motion. You know, for the most part, if we have network functions that exist in the 5G core or even application functions, those functions are probably capturing a set of data. The data that they're capturing is probably to generate KPIs and metrics so you can understand the network, which is great. But there's other data sets that we may need. So we need to have a way to capture those. And the reality is we want to leverage our SDN rollouts, our cloud native environments, such as service mesh architectures, and be able to actually take data from those environments. And we want to actually utilize it from a data plane programming perspective. And what I mean by that is when we're implementing these things, why can't we push more intelligence to the lowest layer possible? We've built up these networks. Most of them are very software oriented, so we can support very efficient processing. Sometimes there are hardware assists. We should be looking to push down not only the data capture, but can we push analytics functions down? Can we push models down in some form or fashion? I kind of always use the example of your phone can take a picture and identify a cat, but the ability to do that was, you know, that wasn't all built on your phone. There was an offline function that did that, and then the model was pushed on here. We want to do that same observability capability here as well. And then once we have that, obviously we can do things that are more real-time triggered. We can drive it from our analytics functions or other events that are occurring in the network. If we look at the model lifecycle management, what are we talking about? Well, there's a whole DevOps craze and CI/CD. There's a similar path that we want to take for machine learning and modeling. It's MLOps. It's really just machine learning plus DevOps. So if you're familiar with the whole figure 8 in terms of how you're going through a DevOps environment, just bolt on one more circular loop into that, and now you actually have a front end of machine learning analysis followed by the DevOps process. But we're doing this not for apps, but maybe for the models themselves. So you can see the diagram here. The first 3 or 4 bubbles are probably well known for those that are doing machine learning algorithms. We want to collect the data, we want to prepare the data, feature engineering and so forth, and then train the models and deploy. What's been lacking is what do we do next, and how do we actually make this a product? And that means that we need to build in monitoring of the models themselves in terms of accuracy. How are we going to do that? Well, we need to actually have intelligent observability so that we can grab the ground truths on a semi-regular basis in order to actually check the models for their accuracy. And then that'll push a retraining step, again, which can be automated. And if those results come out right in terms of the train, test, and deploy cycle, then we can push that model back out. If they don't come out right, then maybe we have to bring in a DevOps function of doing more machine learning analysis because the data has changed in some form or fashion. So from there, now we'll end up having the ability to share more ML models. With this whole ML ops or model ops approach, we can now leverage back-end tools, whether that's from the IT department or even the hyperscalers tool chains that they have. So this allows you to decouple the analytics functions that you may have deployed for your 5G environment from the rest of the tool chain. And it really bolts those two pieces together, as Jennifer was talking about. And we'll need a way to standardize and push models in and out. Right? We want to be able to import and export these models from the various systems that we're using, and then achieve a continuous training cycle there. And then finally, looking at things from an integrated orchestration perspective. Here, we're looking to really move out of the silos of everything has to be done within one domain, say 5G core, and we're working all through that. That works out really well in terms of delivering on the pieces that are required for that domain. But what if we actually want to manage the network holistically? We should be looking at the orchestrators, the SDN orchestrators that are in the IT data centers, the core functions, the edge orchestrators that are supporting either on the RAN side or on the MEC side, as well as even the lower layers in terms of how are we backhauling, what's the front haul, and the overall IP network that's driving this and the transport layer. So we'll need all of those layers. And what we would want to do with those is effectively leverage their declarative and intent-based programming exposures there. With that, we can actually provide common enforcement capability that may transcend the multiple applications and application vendors that are running in those network functions, and basically leverage the more data center centric model versus what we would traditionally be in the past, which was far-flung RAN, core, and transport and IMS-based domains. So what do we get when we bring all of these technologies together? Well, if we look at the applications, maybe we can put them into various categories. Again, these are categories that we are really well understood here in terms of how we've managed networks in the past. We'll want to manage the infrastructure. This is the cloud infrastructure or physical equipment. We'll want to do network operations such as planning and so forth. Network assurance, this can include service assurance and customer experience management. Service orchestration, being able to roll out new capabilities on demand, as well as network security. So from here, if we overlay that with the new programmatic building blocks we were discussing, we can start layering in maybe deeper, richer application use cases. So optimizing a data center, this is probably front and center on many of the hyperscalers and many of the service providers in terms of how they want to optimally utilize all of their compute. But in reality, if we only take in the operational data that's maybe coming from Prometheus and so forth, this could be CPU and memory and storage and so forth, those traditional aspects of cloud compute, that's one piece of the puzzle. But what if we want to tie that to how well are the services running as we actually have these correlated data sets? We don't need to keep these separate, so we may want to fuse this data together in real time and make measurements continuously, and then maybe push that data into a model that actually does some sort of efficient packing. Here I have a neural network knapsack doing that. And then we push off a recommendation for a new layout. And when I say recommendation, this could be an intent-based recommendation that's going towards an orchestration function there. Similarly, we could look at operations and look at it purely from, okay, well, when we're collecting data, how do we know that the data is accurate and works over time? We're working in a CI/CD model where we want to continuously push out upgrades and updates of the network functions. That means the life cycle of doing testing before we do a deployment has actually been shortened. So we need to manage that accordingly. And we may actually see changes in the underlying data. So we could have two network functions that are delivering, or two of a network function from two different vendors in the network that are delivering event data. We may actually want to analyze that data so that we calibrate it to make sure that they're both measuring in the right way. This could be after an upgrade or as we roll out, another vendor best of breed capability there. And this allows us to at least ensure that the measurements that we're talking about standardizing, are accurate between each other. On the network assurance side, again, we have all these KPIs that actually measure the network and realize whether it's working at 90, 95% and so forth. So this is great. But what if the network has an issue? How do we actually analyze and find where that issue is occurring in the network? We need to dig one level deeper there. So here I'm actually showing a modeling of a threshold. And in some cases, we're taking the data from intelligent observability and pushing a model that pushes over to orchestration. Here I'm showing this model is trained so that we can push thresholds back into the intelligent observation layer. So the little left arrow there. And the idea being, can we automatically determine when there's a problem going on in the network, and then maybe do something like in-band network telemetry, gather the data across the entire network hop by hop based on a trigger that we've pushed into the observability layer there. And then from there, maybe there's a recommended action in terms of a fix. And we can continue on in these applications. Another example would be end-to-end slice management. Again, we're looking to realize maybe we don't want to actually have slices to be hard built up, but we want to trigger based on the amount of traffic for a particular service or application, and when it crosses that threshold. And then we could spin up a slice. So here, being able to monitor the network and realize when we need to apply more resources or particular discrete resources for services is something that would require an automation capability by analyzing the offered data that's going on in the network. And then there we could provision and deprovision slices as needed as the traffic ebbs and flows. And finally, from a security perspective, looking at it here, we may want to actually program into the network anomalies that we may find. So this could be simple baselining in terms of we don't normally see this many connections going on, from a single server or across the board. Maybe there's a burst of connections or connection failures. We could trigger on the heaviest users that may be causing this, and these can all be built into the data plane layer, and then that data comes out and we determine the most probable cause of a failure and then potentially recommend an isolation. Maybe it's only occurring in one portion of the network, and we could use edge compute to do isolation techniques there. So I'll stop there, and then I have another poll question here for you, Jennifer.
All right, thanks, Chip. So very interesting information. So let's catch up with what our audience is thinking about in terms of this question. What real-time applications are you likely to deploy in the next 18 months? And you can select all that apply here. Are you going to be looking at infrastructure management, network operations, network assurance, service orchestration and management, or network security, or network security? So Chip, what do you think the responses are going to be? Are we going to see a lot of, I always expect to see a lot of response for network security, but there's an ebb and flow depending upon the audience. So what do you think we're going to see?
I mean, I think it probably starts with assurance. I mean, we want to make sure that the network is running properly. Some of the other stuff may, in terms of really getting to a real-time nature of it, may take a longer time, like infrastructure management and so forth. I think they're a kind of a ideal situation, but we may not. We may prioritize those a little lower. I do agree. Security, though, is pretty high. Should be pretty high.
Yeah, it should be. I think we have enough responses here. Okay, so as I say, there's an ebb and flow there, so fairly low, although 23% is not chump change. But network operations, number one. What do you think of that?
Yeah, I guess this kind of talks towards everything that you presented, which is as we're doing a cloud native architecture and pushing out these new compute environments, maybe this is the first area that we need to really understand.
Yeah, network operations, and then how we're managing it, what the service orchestration and management is behind this. So definitely. All right. I'm going to hand it back over to you.
All right, this is more the wrap-up slide. So last mile of automation, I think you can see my perspective and my opinion of it. I feel like we're doing all the right things in the standard as it relates to defining APIs in order to support the integration across a number of functions. But in reality, we can do a lot more in order to actually really be able to deliver on the use cases and the ideas of what 5G is looking to do. We're now going to be at scales that are 10x and maybe even 100x of what service providers have had to handle, assuming 5G takes off. So we'll want to automate as much as possible and is deeper than the traditional analytics that we tend to realize. There's a industry service group in Etsy called Experiential Network Intelligence, and they basically come up with a maturity model on automation. And effectively, what I'm talking about today in terms of adding maybe intelligent observability and model lifecycle management and orchestration, that's at about a 2 from a range of 0 to 5, where 5 ends up being fully autonomous networks that are self-healing and doing all of these things. So we really have a way to go, and these building blocks that I'm describing really just kind of scratch the surface of where we want to get to. We want to keep on building on the functions below. And really, we're probably moving from a cloud native industry to an AI native industry, right? We really want to continue to grow this path so that we're pushing and automating as much as possible, and then coming in with a human decision based on the results that we're seeing there. So really appreciate everyone's time today. And back to you, Jennifer.
Thank you, Chip. So moving from cloud-driven to AI-driven, very interesting and sort of required with the increase in sites and traffic and the meshing of cloud and enterprise and consumer. So very interesting. We have a bunch of questions. For those of you who would like to ask a question, please do it via your console. But let's get started. Here's our first question. Since your AI solution manages sensitive information, how do you comply with GDPR regulation in terms of privacy and data protection?
Yeah, I mean, this is something that we've had to deal with, ever since the start of analytics to some degree, and it really does range country to country and carrier to carrier. We support a number of capabilities that allow for anonymization of traffic. We don't always need to know the exact subscriber or where their locations are. We can actually do one-way hashes on those things in order to do some, say, training models and so forth. What we do find, though, is that the service providers themselves they need to actually know the subscribers. So we have to also build in the capability for, if we're sharing data in one direction, it may be anonymized appropriately. And then in other cases, we have the proper AAA, and by AAA I mean authentication and so forth, capabilities in order to ensure that the right users, with the right roles are accessing the data that may be subject to GDPR or PII information.
Very interesting. Okay. Our next question is, please provide an example of intent-based network programming.
Yeah, I would say intent-based network programming is more along the lines of what you want to achieve versus how. So if we really want, in those applications that I was enumerating, if we really want the ability to have full autonomy in automatic networks, then we can't really get down to the nuts and bolts of do this function, perform that, and so forth. So instead, I'll give an example, is probably more along the lines of you need a secure connection, between these two elements, and not how it's going to be achieved. And then AI and ML are doing transformation models for, say, language, right? You can go from speaking voice to text and so forth. You can go between languages. Techniques like that can also be used to be able to transform, high level what requests to how requests, through these orchestrators.
Yeah, it's a little bit scary for the CSPs, isn't it? When you say, hey, these are the characteristics that I'm looking for this workload. It needs to be such and such latency, these KPIs in terms of security, in terms of performance. Go get me, go establish a session that is going to meet all these KPIs. Boy, it's a challenge for the carriers to let go of that control, isn't it?
I think that it's a road, right? And it's a journey in terms of the transformation. And I think we have to continuously, define the services and the architectures better so that the abstraction levels are there in order to achieve that. But yeah, it's certainly early days in this intent-based network world.
Exactly. Okay, let's move on to our next question. What programmable data plane technologies are supported?
So, yeah, I think from this perspective, obviously, if we're looking at cloud native applications, then, the service mesh architectures and so forth may have their own architecture of what they've supplied there. And that's like on a pure software level. If we look at it from the hardware side, what's been done there on SDN is probably along the lines of Intel's P4 programming language, which allows you to actually start programming the data pipeline that's going through the switching and the data center switches there. I think there are other technologies, Broadcom, network language programming, I think NLP it's called, or NPL. So those are the types of things that are occurring at the kind of really hardware nuts and bolts level. And then maybe popping up a level, there's network operating systems that are actually exposing a lot of these capabilities in proper APIs. And when I was talking about orchestration and integrating there, I envision that programming those network operating systems will then end up taking advantage of those underlying hardware acceleration capabilities and APIs that are there.
All right, excellent. Our next question, is there an application opportunity for massive IoT here?
Probably the quick answer is yes. I mean, I think if we're automating, obviously we're looking to be able to handle that level of scale. I think the issue in terms of automating is, what is the data that we're collecting? Because some of the massive IoT, or MMTC, I think it may be called, whatever the acronym is in the standards, they end up to being highly verticalized solutions that have their own data sets internally there. When I look at it from the, say, service assurance perspective, if we look at, some of the analytics we may perform, it really ends up being like, what does that data look like when we're analyzing it on the wire without actually being able to understand the apps themselves? But defining maybe different levels of SLA support that's required for these various IoT functions in various industries, industrial 4.0 or otherwise, then we can tie those pieces together to realize the what models and understanding we want. And then moreover, we might be able to do, service orchestration by managing slices for these similar massive IoT scenarios if they're popping up ad hoc. So I think there's opportunity there where, just as you noticed in your blue line, when you were describing apps that were above and below, say, the ultra-reliable low latency, there's a similar kind of line probably for MMTC type support.
Okay, very, very interesting. We had a more detailed question on the same topic. I don't know if Well, let me just read it off. I think you've answered a lot of it, but could Chip talk about how 5G new radio / 5G core standalone is helping support incoming massive IoT sensor data and any specific massive IoT analytics features?
Yeah, this is probably a new area. I mean, I would say we could probably dig into that a little more, in an offline discussion. I think probably what I just described before is, along the lines of my position on it at the moment. I do think that there's more to come on the MMTC side of the house.
I hear you. And let's see, if people have questions, please let me know. But here's our next one. Why would a mobile network operator go directly to 5G standalone instead of non-standalone and the 4G EPC, given the necessity they are facing in still monetizing 4G core investments? So is there a money path there?
Yeah, no, I guess obviously even 5G has the big question mark in terms of building it. Why are we building it? Are we going to monetize it, right? Especially from the slicing perspective. I mean, I would say maybe some point use cases could be fixed wireless access. So you may want to build out a 5G SA environment that really just supports your internet connection from a home or businesses. So that may be one example. Maybe private 5G, which is obviously a 5G SA solution. So if you wanted to stand up private 5G networks within industrial and or enterprise locations, that's an SA variant there. And I think service providers are certainly looking at that market as well. Even enterprises are looking at that. So I think there's various reasons to embrace 5G SA before you're actually closing out on your 4G side, or even continuing to monetize or get a return on investment on what you've deployed there.
Yeah, we've seen a lot of the rollout of 5G is unprecedented in terms of how fast it's been, in terms of the number of subscribers, and in terms of the 5G RAN. So that has rolled out very, very quickly. However, it's going to take a while for the 5G core to catch up with it. But now we are seeing a lot of momentum there, specifically because of the need to, if the carriers are going to be flexible, if they're going to move towards the type of agility that they need to move to cloud native. And if they're moving to cloud native, there's 5G, and the 5G core and cloud native are sort of very tightly linked. So if you're moving to 5G core, one of the reasons is because you're looking to leverage some of the capabilities that come along with cloud native, isn't it? In terms of a lot of the network slicing capabilities we've been talking about, support for low latency, support for distributed intelligence. So they're pretty tightly linked, aren't they?
They are, and I think it really ends up being like what you described before, which is the first mover.
Yeah,
there will be the first movers, but there's also a healthy portion of MNOs that have just recently rolled out their LTE, and then say their VoLTE on services on top of that. So obviously they're not moving away very quickly. There may also be some greenfield scenarios where maybe they can actually stand this up and it's a competitive advantage for them. So there's definitely a range of scenarios there.
Absolutely. That was our last question. So at that point, I'm going to thank everyone in our audience for listening into our webinar. And thank you, Chip. Very interesting conversation. I learned a lot. And
me too, Jennifer. Thank you for providing all those details too.
Good. And with that, I'm going to close it out for today. So thank you all for attending.
Yeah, thank you.